Good evening, students. This evening we're going to do Module 3, Topic 1, Conjectures and Counterexamples. Our standard is LT 4.10. Judge the validity of arguments and counterexamples to disprove statements. The objective for this lesson, you guys are going to analyze conjectures by using inductive reasoning and disprove conjectures by using counterexamples. For the bell ringer, says use the pattern shown to make a prediction. Complete each statement. I want you to pause the video here. I'm going to wait 3 seconds and continue. Just work this bell ringer by yourself. Alright, number 1. Excuse me. We have 3 squared is 9, 5 squared is 25, 11 squared is 121, and 17 squared is 289. It says the square of an odd number is a blank number. So we have odd, 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 odd. So the square of an odd number, so 3 squared was 9, 5 squared 25. So the square of an odd number is an odd number. Number 2. 4 squared is 16, 8 squared is 64, 14 squared is 196, and 20 squared is 400. The square of an even number, so these are all even. So 16 is even, 64 is even, 196 is even. The square of an even number is an even number. And then number 3 here, we got 2 plus 5 is 7, 15 plus 4 is 19, 22 plus 13 is 35, and 14 plus 37 is 51. The sum of an odd number and an even number, so odd, even is odd, odd, even, odd, even, odd, odd. So it looks like the sum of an odd and an even number is also an odd number. Alright, guided notes. Let's just scoot here. Inductive reasoning is the process of reaching a conclusion based on a pattern of examples. When you assume that an observed pattern will continue, you're applying inductive reasoning. You can use inductive reasoning to make an educated guess based on known information and specific examples. This educated guess is also known as a conjecture. Okay, just below we got our first I do. Write a conjecture that describes the pattern in the sequence. Then use the conjecture to find the next term in the sequence. So we have appointment times. We've got 8:30 a.m., 9:15 a.m., 10 a.m., and 10:45 a.m. What do you notice between these times? Well, let's look. So from 8:30 to 9:15, well, that's 45 minutes. 9:15 to 10, that's 45 minutes. And that's 45 minutes. So our conjecture is going to be that appointments are 45 minutes apart. Okay? So they want to know the next term. So if we add 45 minutes to 10:45, we get 11:30 a.m. Just for giggles, let's go one more. So if we add 45 minutes to 11:30, we end up with 12:15 p.m. Alright, number 2 is a you do. I'm going to pause for 3 seconds, ask you pause the video, try this one on your own, then unpause and compare answers with me. number 2. Write a conjecture that describes the pattern in the sequence. And then use the conjecture to find the next term in the sequence. And so we have 1, 2, 4, 8. Okay, so, well, 1 to 2, that's 1 more. 2 to 4, that's not 1 more though. That's 2 more. I wonder if it's 1, 2, 3. 4 plus 3 would be 7, so nope, that's not it. No, but if you double 1, you get 2. If you double 2, you get 4. If you do 4 times 2 or double it, you get 8. So these numbers they're doubling, or we can just say they're multiplying by 2. So 4 times 2 was 8. 8 times 2 would give us 16. 16 times 2 would give us 32. Alright, number 3. Make a conjecture about the sum of 2 odd numbers. Okay, we remember back to elementary school math, the sum, that's going to be when we add. So 2 odd numbers. Well, let's say 3 is an odd number and 5 is an odd number. Makes 8. Okay, let's say 7 is an odd number and 9 is an odd number. Let's see. 1 is an odd number and 13 is an odd number. Even, even, even. So the sum of 2 odd numbers So the sum of 2 odd numbers is an even number. If you want to know the mathematical symbol for sum, it's like this. But that's for another class. Alright, number 4. This is another you do. You're going to wait 3 seconds before proceeding. Please pause the video. Try this one on your own. Alright, number 4. Make a conjecture about the product of 2 odd numbers. So product, that's going to be if we multiply. Let's say, let's just use the same numbers here. So 3 times 5 is 15. 7 times 9 is 63. 1 times 13 is 13. So the product of 2 odd numbers is an odd number. Just write the pound sign number there because we're running out of space. Okay. Let's flip over here to page 2. This is a somewhat short lesson. Alright, page 2. The table describes the population of flies in my trash can. Write a conjecture that describes the pattern in the sequence and then use the conjecture to predict how many flies there will be in 5 days. So we got 4, so we want to go to day 5. So let's see. Day 1, we have 3 flies in my trash can. Day 2, 9 flies in my trash can. Day 3, 27 flies in my trash can. Day 4, 81. So what are these numbers doing? Well, if you can't tell, so 3 and 9. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So these flies are tripling, or so they're growing by 3 each day. So we would multiply 3 by 81. Just verify my math here. Glad I did. So day 5, we're looking at 243 flies. So I'm getting a new trash can. But that's the answer here. Alright, let's scoot 6 over here just a little. I can make this light a little better. 6 is a you do. I'm going to wait 3 seconds before I proceed. Please pause the video here and work number 6 before you unpause. Alright, number 6. Brooke is practicing her deadlifts in the gym. She increases her weight every set. The table to the right describes her workout. Write a conjecture that describes the pattern in the sequence. Then use your conjecture to predict how much weight she'll lift in her 6th set. So we have sets 1 through 5, so we're looking for 6. So set 1 was 255. Set 2 we went to 285. Let's see, 285 minus 255, that's 30. Okay. 285, next she lifted 315. 315 minus 285 is also 30. 315, if I were to add 30, that'd be 345. 30 more. Okay, so she is increasing 30 pounds per set. So we're going to add 30 there, and then on her 6th set she is deadlifting 405. Pretty well. Alright, got some more guided notes. Alright, I got notes. To show a conjecture is true for all cases, you must prove it. So, sounds like science class, but we're still in geometry. It only takes one example that contradicts a conjecture, however, to show that a conjecture is not always true. This example is called a counterexample, and it can be a number, a drawing, or a statement. So let's look to the left here, number 7. Anna was having a picnic. She noticed the sky was blue until it started raining. She made the conjecture, when it's not raining, the sky is blue. Provide one counterexample to prove Anna wrong. Here, this is just really anything you can think of that can contradict the statement. So, when it's not raining, the sky is blue. Well, have you ever seen it cloudy and not raining? Yeah, me too. So, a cloudy sky without rain. Kind of paraphrasing here to give us less to write. Let me know in class if you guys got anything different on this. Number 8, another you do. I'm going to let you pause here if you'd like, or we can keep going. These are kind of, this type of work really, it's whatever you come up with. So number 8 says that Linda started working at the DMV last week. She conducted 3 driver's tests that week, and they were all for 16-year-olds. She made the conjecture, all 16-year-olds can drive. Provide one counterexample to prove Linda wrong. So I said in class today, for the ones that were there, if you were 16 and you don't have your license, or you haven't started driving yet, is a counterexample. But another one, she conducted three tests. I'm assuming they all pass because of what she said here, but what if one of them failed? So if well, it'd still be the same thing. We have a 16-year-old who doesn't drive. Okay, moving on. Just about done with this real quick here. Ugh, sorry for the lights there. Okay. Number 9. Find a counterexample to show that each conjecture is false. So we have some math here. So for A, I'm sorry, let me back up and read the line before here. So if n is a real number, then n is less than n cubed. Select all that apply. So for number 1, n is -3. Okay, well, so let's say -3 cubed. So -3 times -3, or -3 squared, would be 9. And then you add -3 again to cube it, that's going to be -27. Well, -3 is greater than -27. -27 is a smaller number because it's negative, so that one's not true. Try to switch gears here. Okay, for B, we got that n is a fourth. Well, if you cube a fourth, you get approximately 0.016. Let me verify that. I'm going to pause. Hold on one second. So this guy is false as well. Part C, n is 1. Well, 1 cubed is 1, and 1 is equal to 1, so this guy's not true. Look over here, n is 5. If we multiply or cube 5, 5 times 5 is 25 times 5 is 125. And in this case, the cube, the 125, is greater, so it's a good one. And then lastly, 100. If you cube 100, you get 1,000,000. What was it? Hold on, let me count my zeros again. Yeah, that's right. And obviously, 100 is less than 1,000,000. So, that one's good. Alright, take a second. Pause, do number 10. Come back together here momentarily. Right, number 10, find the counterexample to show that each conjecture is false. If n is a real number, then -n is a negative number. Well, to make this very simple for us, let's say that n equals 3. Okay? Well, if the negative n is going to equal -3. Oh, I wrote that backwards. So this proves what they said. Good job, teacher. Alright, so if we say n equals -3, the negative n is going to equal +3. So this is the opposite of what they're saying. So so skip this. This was wrong. But if n is -3, then negative n would be +3. So this would not be true here. If n's a real number. Alright, last two problems for Module 3, Topic 1. Find the counterexample to show that each conjecture is false. And actually, this one here, there is a missing. There's a missing picture. I know the answer. I have the answer from the book, but I can't seem to find the actual image. this problem is asking us about saying if angle ABC is congruent to DBE, then ABC and DBE are vertical angles. And the answer I had says the image shows that angle ABC is equal to DBE, but they are not vertical angles as points A, B, and D are not collinear. So I'm assuming I know what that looks like, but we're just gonna kind of mark this one off for now. We're gonna go over here to number 12. We'll work this one together. So find the counterexample to show that each conjecture is false. If a line intersects a segment at its midpoint, then the line is perpendicular to the segment. Draw a diagram to represent the counterexample. So over here in blue, they're saying, so this is A, this is B, and C is in the midpoint. The line comes here, it makes a 90-degree angle, it's perpendicular. Okay, well, let's do this again. A, B, C is the midpoint. Well, let's say the line doesn't come straight at it. Let's say it comes at a small angle here. So this is not a 90-degree angle. So it's not perpendicular. So it negates this. It's a great counterexample to what this conjecture was saying. So this is, it can happen this way, but it could also happen this way. So that conjecture is false. Let me know if you guys have any questions. Hope you have a great night, and we will see you in class soon.